is infinity, right? So I should do this. 1 to b. I should take a limit b equal to infinity. Okay, of this. Alright, so this is equal to what? Let me do it slowly, okay? So substitute x by b, right? Minus substitute x by 1. 1 to anything is 1, so this is 1 over minus p plus 1. Okay, now I'm going to let b go to infinity. Alright, now note that this. So if negative p minus 1, if this is a negative number, what does that mean? That means this is actually a denominator, right? So when b goes to infinity, this term will drop, this term will go to 0 if this is less than 0. And therefore, since this drops 0, so this guy, 1 to infinity f of x dx is equal to this number. So it's minus 1, minus plus, so it's p minus 1 equal to this. If negative p plus 1 is less than 0, then this integral is 1 over p minus 1. And this is really nothing but, if I move this to this side, it means nothing but p greater than 1. P greater than 1 is the same as minus p plus 1 less than 0. So if p is bigger than 1, then this integral is 1 over p minus 1. Aha, so what that means? This means this is convergent, because it has a value. So if p is greater than 1, this summation 1 over k to the p from 1 to infinity is convergent. If this p is bigger than 1, then this is convergent. But on the other hand, if, look at this one, right? If minus p plus 1 is positive, if this power is positive, then b to the minus p plus 1 would go to infinity. Because if this is positive, this is a big positive number, when b is going to infinity, when b goes to infinity, this thing will go to infinity. Therefore, and so this one exists. So in this case, this function is divergent. So therefore, that is to say, summation a k from 1 to infinity is, I'm sorry, it's 1 over here, 1 over k to the p, k from 1 to infinity, where this minus p plus 1 is less than 0, that means 1 is less than p, so 1 is greater than p. So if p is more than 1, this is divergent. If p is less than 1. So we can summarize what we have done so far. This series from 1 to infinity is convergent if and only if the p is bigger than 1. This is called p series. We have a name for this, called p series. P represents this p. So they will call it p series. For summation 1 over k to the p, this thing is convergent if and only if p is greater than 1. If p is 1 or p is smaller than 1, it is divergent. Okay, and this one is, this is what it is, okay, in both. P series, let's see what it is. They talk about this here in the example. It seems I don't see it here. They go P series. So, yeah, here. This is on page 632. The P series. Okay, another one. Page 632 in our textbook. All right, let us do some exercise here. Exercise. So the problem that I assigned in section 8.4, those problems are 9 to 33 are number. 9 to 33 are number. So I'm going to exercise 8.4. Okay. Why don't we do number 9, because that's first problem, so got to be simple. Okay. All right. So what is first number 9? Okay, divergence test. So all this group of problems from number 9 to number 16, number 18, those are divergence tests. Okay, I'm going to the instruction book. So it says, use the divergence test to determine whether the following series diverge or state that the test is inconclusive. Okay. So what the divergence test is, let's see. Divergence test says that, if the nth term of the series does not go to 0, then it is divergent. So if the series an is does not exist or if it exists but not equal to 0, then the series is divergent. Now, what if limit an equal to 0? Well, then it is inconclusive. Okay. So if limit an go to infinity equal to 0, then it is inconclusive. Okay, inconclusive whether the series is convergent or not. So in other words, you have to use a different method, whether the series an is convergent or divergent. The series, if the limit of an is 0, then the series, then it is inconclusive. Inconclusive means you cannot be sure whether it is convergent or divergent. So we use the word inconclusive. Inconclusive. You cannot give a conclusion. That's what it means. You cannot give a conclusion. If limit an equals to 0, then it is inconclusive whether series an is convergent or divergent. All right, so let's look at number 9. What is number 9? Well, you look at this, number 9, right? Summation k over 2k plus 1. K is from 1 or 0. It's difficult to see, but I think it's 0. Yeah. 0 to infinity. Okay, or doesn't matter where where the k starts. This is the kth term. I need to check if this goes to 0. Now, when k goes to infinity, both numerator and denominator go to infinity, so we can use L'Hopital's rule. Which actually is done very simple. K approaches infinity. Derivative of k is 1. Derivative of 2k plus 1 is 2. So this is 1/2. Well, 1/2 is not 0. Therefore, the answer is what? Divergent. Okay? All right, let's look at perhaps another one. About, yes? Oh, yes, you see. Any question? Okay. All right, let's look at maybe another one. Yeah?
Before when you said if the limit is equal to 50 and 0 is inconclusive, why?
Before, which page?
That page.
This page?
Why is it inconclusive if it is 0 in that box?
Why is that? Why is that?
Inconclusive.
He wants to know why it's inconclusive.
Why is that? Limit? Which line you have question? This one?
Yeah.
Here, yeah. So this thing says if the limit of a is not 0, then this is divergent. But then the question is that if this is equal to 0, can we give a conclusion? The answer is no, you cannot do a conclusion. So if this is equal to 0, then it is inconclusive. I hope you can read this handwriting. Inconclusive. Inconclusive, whether the series, whether this series okay AN is convergent or divergent. We cannot conclude anything. That's what this means. Okay. If it's not 0, if the limit is not 0, it is divergent. But if the limit is 0, we don't know. That's the
You're
point.
saying we just can't start with that.
And so say it again.
Are you saying we cannot start with?
Right, we cannot do. If this is 0, you cannot say whether it's divergent or convergent. Okay. So that's why I have this word inconclusive. So we don't know. But what this means is that you have to use different method. You cannot use this method. Yeah. What this inconclusive means, you have to use different method. Okay. In this way, you have to use. If this equal to 0, you have to use a different method to decide whether it's convergent or divergent. Okay. Right? Okay. So now when we apply this theory into number 9, you see, this is my AK, right? And the AK, limit of AK, well, it's 1/2, which is not 0. So I know that this is divergent. All right? Does it so far make sense? So, for example, if the weather is good, I'm going to go to park. Okay? But what if weather is not good? It is inconclusive. I may go to park if I have umbrella, okay, or I may stay at home if I don't have umbrella. So it's inconclusive. Same thing. Logic. Okay. All right. Let's look at yes.
I was just wondering, like, what's the difference between like the problem we're doing here and the problem we did is like 8.2? Because
The problem 8.1.
I think it was like serious because we would take the limit.
This is 8.4, right?